Welcome to section 2.2. I can compare and order rational numbers. Hopefully we know that comparing is something that you do to describe the relationship between two things. If I were to describe, I have this many apples and you have this many apples, you could describe those two things by saying that I have more than you have, or something like that. So just kind of comparing is describing between two things. Rational numbers, remember, are those numbers we can write as fractions, represented as fractions, as repeating decimals, or as terminating decimals. Starting on page 91. Comparing and ordering. Comparing. Sometimes you can estimate to compare rational numbers. Another method is to rename using the least common denominator. Another vocab, and I think it's on your sheet as a review word, so we should know what it is, but just to review, least we know is smallest. Common would mean something they share, and denominator we know is the bottom of a fraction. So if we were looking at replacing less than, greater than, or equal to in the space between 5/8 and 3/4, we're trying to find out which is more, which is less, or are they the same? So what I can do in this case is, well, I know 5/8, and I'm trying to compare it to 3/4. I can picture these separately, but maybe not the same. What I do notice is that the denominator here is 8, the denominator here is 4, and I do know that 4 can go into 8. So what I'm going to do is change so that they have a common denominator that is 8. So I'm going to change this by 2/2. Because if I multiply, when this is really 1, I'm not actually changing the value. I'm just changing how I'm looking at the numbers so the denominator is the same. So then I get on the top 6 and on the bottom 8. Well, now I see 5/8 and 6/8. And since fractions represent a part of a whole, well, and say I had a shape that is broken into 8s. Let's see if I can do that. There's 4. 8 of them. If I had 5 out of 8, that's that many. 6 out of 8 is 1 more, so 5/8 is actually less than 6/8. So you can try that with these two. Find a least common denominator, the smallest number that they both have in common. Okay? Least common denominator. I see 4 and 12. I know 12 is a multiple of 4. So I can adjust this by getting the denominator to 12 by multiplying by 3/3. So now it's really 9/12 compared to 7/12. Well, I know 9 is greater than 7. 5/6 and 7/8. Maybe I'm not sure what my least common denominator is, which is really my least common multiple of my denominators. So maybe I list them. Well, this is 6, 12, 18, 24, 30. 8's multiples are 8, 16, 24, 32. So what I notice is they both share 24. So in this case, I'm going to have to multiply 5/6 by whatever gets me to 24, which happens to be 4/4. I'm going to have to multiply 7/8 by what gets it to 24, which is 8 times 3. So I do 3/3. 4 times 5 is 20. 4 times 6, we know we're going for 24. 7 times 3, 8 times 3. So I know 21 is more, so 20/24 is less than 21/24. I think this is kind of fun. It's just quick facts, multiplication that I know, and I can really compare things quickly. Here I know these are both 1 and something, so I know both know they're greater than 1, so I really just have to compare the fraction part of them here. Marks. What is a common multiple? So my 5s are 5, 10, 15, 20, 25, 30, 35, 40, 45. Well, I know right now that 9 times 5 is 45, so I'm going to change both of them by a factor by multiplying by the other denominator. So I'm comparing And then 2/5 I have to multiply by 9 over 9, because the goal is to get this denominator to 45 and this denominator to 45. So I'm really comparing my numerator values. 4 times 5 is 20, and 2 times 9 is 18. So what I know is, scroll down, is 1 and 4/9 is 1 and 20/45. 1 and 2/5 is the same as 1 and 18/45. So 1 and 4/9 is greater than. Comparing using decimals. We compared using fractions, having a common denominator, and now we can compare by expressing them as decimals, which we did yesterday when we divided. We were able to change 8/9 into a decimal by dividing 8 by 9. And when you do that, you end up with 8/10 repeating. So what you can do is compare them in the hundredths place. So we look at, okay, well, this one has an 8 in the hundredths place. This is a 0. I know that 8 is more than 0. So I know that 8/9 is greater than 8/10. So let's check our understanding on this dividing. 1/3 I have to do. And when I do that, that's kind of a little too high. Put my zeros in. 3 goes into 13. Oh, did I mess up there? Yep, I put a 0 out of 3. 3 goes into 10. 3 goes into 10 3 times for 9. And notice I'm going to keep getting that remainder of 1. So I know that it's going to be 3/10 repeating, and I can write it like this to compare it to 3/10, which would just have a 0 on the end and not change the value. So I can tell that this side is greater than. 11/50ths we can do. So we want them to write it as decimals in this case. 22/100ths compared to 11/50ths. So how many times does 50 go into 11? 0 times. By 210 it goes in twice for 100 with 10 left over. We're going to keep getting that in that 2. So we end up with 11/50ths is the same as 0 and 22/100ths. No remainders. So this decimal and that fraction are actually equal to one another. So you both know here 5/12 we know is a little less than half. 42/100ths is also a little less than half. So we're going to try to find out what this decimal is in comparison to this decimal. So 12 goes into 5. 12 goes into 50. 4 times for 48. 2 left over. Goes into 20 once for 12. 8 left over. And I could continue, but what I already noticed is we're in the hundredths place and we have a 1, whereas this has a 2. So I know that 2 and 5/12 is less than 2 and 42/100ths, because I know 2 and 5/12 is the same as 2 and 41/100ths, and then some. So since there's a 1 there, it's actually less. Word problems. This is when you'd use them in real life. So now that you know the basic skills, let's try to apply them. The average life expectancies of males for several countries are shown in the table. Order the countries from least to greatest male life expectancy. So meaning lives the shortest to lives the longest. So what we would do in this case, and this is just one of those example ones, is write them each, since they're in fractions, write them as the decimals. So, and put them in the hundredths place, that maybe is easier. So Australia is 76 and 9/10, so we just maybe put a 0 on so we can compare it. France, we changed 4/5 into a decimal, which is 8/10 or 80/100ths, and then changed 1/3 to 3/10 repeating. This added 2 zeros on the 75 and changed 1/4 to 25/100ths. So just comparing those, if we put them least to greatest, well, we know for sure the 74s would be the shortest, and I can tell that, well, this is the only one in the 76s, so I can tell that people in Australia probably live the longest. And these two are somewhere in the middle because they're 75. And then it's a debate on who's at the end with those two. So from least to greatest, and when it asks you to order the countries, I would order the countries by their name. Make sure you're doing by the name and not by the numbers. So you associate 76 and 9/10 with Australia and 74 and 25 hundredths with the United States. You list them by their country's name. Sophia has 5 wrenches measuring 3/8 of an inch, 1/4 of an inch, 5/16 of an inch, 1/2 an inch, and 3/4 an inch. What is the order of the measures from least to greatest? So since they're all already in fraction form, my suggestion is to change them with the least common denominator. No sense in doing all that division. So I'm just going to write them out and kind of look for, we're at 3/8, okay, and look for what number do I think that the denominators all can be multiplied to. What's a common multiple of all of them? And I see they're all even, 2, 4, 8, and 16. So obviously 16 is my highest number, and I can't reduce 5, but I do know all of these other numbers can get to 16. So I have 5/16, and that's kind of just going to stay there. I'm going to try to write 1/4 out of 16. So to do that, I have to multiply by 4/4. So I know 1/4 is the same as 4/16. I can change 3/8 to be out of 16 by multiplying by 2/2. So then I get 6/16. And I can do, so I've done this one, I've done this one, this is already there. 1/2 needs to go to 16ths. So I multiply by 8/8. So it's 8/16, which makes sense because 8 is half of 16. And lastly, 3/4 to get to 16. Again, I have to multiply by 4 for 12/16. So now if I wanted to list them smallest to greatest, well, my numerator is really now what I'm comparing. So I have 1/4 is 4/16. So these are my values I have: 4/16, 5/16, 6/16, 8/16, and 12/16. But I want them to list my original values, okay? Not what I have now, but my original ones. So I see that 4 is my least numerator, so 1/4 must be my smallest value. My next up would be 5, so 5/16. And then my 6/16 would start it as 3/8. And then my 8/16, which is, oopsie, see, I want to write my original. So my 1/2. And then finally my 12/16, which was originally, I'm not going to write as 12/16, it was originally 3/4. So that is in order per wrenches least to greatest. Again, comparing on 93. Just as positive and negative integers can be represented on a number line, so can positive and negative rational numbers. So, so just like sometimes we get confused on which is larger, -6 or -5, because we know the absolute value of -6, that's a larger absolute value, but it's actually less. So you got to be kind of on the same regard with negative fractions, is that just like our whole numbers, it's a little bit backwards. So it looks like the more negative you are, the further left you are, which means the smaller you are. You can use a number line to help you compare and order negative rational numbers. So you can use those as long as you know how the number line works, and that the furthest left is always the smaller one. The further right is always larger. You can kind of compare these, putting them on a number line. If you put your increments out, look at our increments would be going by 1. This would be, 41 hundredths there, and so on and so forth. Our odd numbers would be in the middle. You could put a 0 on the end here to know that it's going to be over here. And the more that you have on the end, you know, the thousandths, the hundredths, and all those places add on to the number. And since it's more negative, this number here, negative 45, negative 2 and 45 hundredths, is actually going to be less than. So negative 2 and 4 tenths is going to be greater than because it's further right on the number line. So I know that can be tricky because without that negative, you'd think they were twisted around, but they are negative, so it's a little backwards. Always put the negative on top of your fraction. See how this can get a little bit, I don't know what that is. I usually just would write negative 7/8. It just makes it a little easier to see. So negative 7/8, we see that since the denominators are the same, we really just compare the numerators. And I know, based on my number line or whatever, that negative 7 is further left, so I know it's less than negative 6. That makes the whole thing less than the other one. So you can try here. Maybe you need a number line to compare negative 3 and 15 hundredths to negative 3 and 17 hundredths. Since they're negative, the one that is a larger absolute value is going to be further to the left. So maybe I had on here, I have negative 3 and then negative 4, and then the increments of, tenths, 2 tenths, 3 tenths, 4 tenths, and so on. I'm going to have 17 is going to be further left than 15, so I know that this is actually greater than, because this would be further right. Negative 7 tenths compared to negative 4 fifths. Again, I want common denominator, so I'm going to change this by 2. So I'm really comparing negative 7 tenths to negative 8 tenths. Since negative 8 is less than, it's further left on the number line, negative 7 tenths is really greater than. If you looked at your number line, negative 8 would be here, negative 7 would be here, whether it was a fraction. And so since this is further right, it's greater. All right, that was kind of a quick run through, a little bit of review vocabulary, nothing new, just the least common denominator, and kind of using those words while you talk about the math, because while you use math language, you're going to understand the math a lot better. So go back, rewind, use your book, use the online book, bring your notes to class and have them get checked, bring your questions, and really make sure you're asking questions when you come to class.